Hi, everyone. My name is Omid Chokufande. I'm the president of the Penn Club of Los Angeles, and I want to welcome everyone tonight. Thank you for making it out. We have people, alumni from 2 blocks away, and we have alumni all the way from Long Beach, so good to see that people are making it out for this event. We're excited to be hosting this one. I think this is a really, really cool opportunity to speak with a current professor who just released a book. And here it is if you haven't seen it yet. It's called The Human's Guide to Machine Intelligence. We host events like this throughout the year. So I encourage you to visit the Penn Club LA website and see what's coming up. If you are not a member, I encourage you to become a member. And one event that we have coming up in Santa Monica is a Women in Tech event. And that's going to be a panel event. It's going to be hosted in Santa Monica. It's going to be a lot of fun. So if you guys want to join, please check out our website. This event space was provided by ZEFR, so I want to thank ZEFR for hosting us. And specifically, one of our board members, Becky Zavaleta, she works here and she helped set this up, so I want to thank her. And I actually want to give her a couple minutes on the mic just to talk about ZEFR, and here you go.
Hi, everyone. How's everyone doing? Awesome. So ZEFR is really excited to host this event because it has to do with machine learning. And funny enough, ZEFR also does machine learning. However, ZEFR not only does machine learning, but we have also learned that using just machine learning pattern recognition itself isn't enough for our products. So we actually have an additional element called human in the loop, which is kind of like getting reviews from humans to make sure our machine learning algorithms are working the way they should. You can think of it as a quality check. And we actually have some engineers from ZEFR, so I'm very happy that they're joining, and so that because we're going to learn about the ethics of machine learning and see what a professor thinks about machine learning, and it's going to be a really exciting time. So thank you again for everyone for joining, and I'll pass it back to Omid.
So without any further ado, I want to introduce our moderator and our guest of honor. I'll start with Chen. He's our moderator. He is a former student and fan of Professor Hosanagar and his emerging technologies class, who went on to Google, where he built most of YouTube's creator services worldwide. Today, Bing is about to launch a mega fund that invests and incubates new companies for new majority communities and interests. And now our guest of honor, Professor Hosanagar, is the John C. Howard Professor of Technology and Digital Business and a Professor of Marketing at the Wharton School of the University of Pennsylvania. Kartik's research work focuses on the digital economy, in particular the impact of analytics and algorithms on consumers and society, internet media, internet marketing, and e-commerce. Kartik has been recognized as one of the world's top 40 business professors under 40. He is a 10-time recipient of MBA or Undergraduate Teaching Excellence Awards at the Wharton School. His research has received several Best Paper Awards, and Kartik co-founded and developed the core IP for Yodel Inc., a venture-backed firm that was acquired by Web.com, and Yodel was listed by Inc. magazine among America's fastest-growing private companies. So with that all said, please welcome Bing and Professor Hosanagar.
All right. Such a treat the student becomes the moderator. This is a real... Oh, go ahead.
No, I wanted... Is this working? Yeah. I wanted to say the introduction was not complete because you were introduced as my student, but we were also classmates. So we were students in a screenwriting class at Penn. And so I have an interest in the film world, and so 1 year, I took screenwriting 1 and screenwriting 2, and that's where we met, and you were in the class with me, and that's how I first met you. So we were first classmates, and then we were student professor.
This is why Professor is more successful than I am, because I was a creative writing major, which is why I was there. You were just doing this as a hobby. So you're the Renaissance man. Anyway, I think as most of you know, not only from the intro, but I think many of you know the professor. We can't call you Kartik. That's so weird.
Why? No,
Dr.
Kartik, please. Kartik is good.
The professor. No, it's such a treat because there are very few people in academia who not only sit at the intersection of multiple technologies and content, but also have actual practical experience in it. No offense to academia. So Kartik, our professor, is obviously a phenomenally successful investor as well as operator, on top of being an incredible academic. So it's going to be great to hear your perspective. We wanted to do 3 things today. One is we want you to have an opportunity to show off your book, and specifically some of the things that it illuminates. Second, through that conversation, you both through your work, but then also through the book, speak to a lot of issues that I think are particularly sort of challenging in the zeitgeist. So whether it involves fake news or otherwise, foreign nations. And then the final thing, we want to have a lot of time to have questions from the audience, because we know whether it's ZEFR employees or otherwise, I'm sure everyone has a lot of things that are on their minds. So why don't we get started with some of the basics? Yeah. First and foremost, algorithm is such a weird word. Everyone has made fun of it. Apparently Al Gore made it too. That's why it's called algorithm. How do algorithms at a practical level actually impact, or most impact, our personal and professional lives?
Yeah, sure. So, I mean, algorithms are all around us, right? Algorithms are quite simply a series of steps one follows to get something done. So when I make an omelet, I follow a set of steps. You could call it an omelet recipe, but a computer scientist would call it an omelet algorithm. So any tech we use has algorithms in there, and they drive a lot of decision making today. So, on Amazon, on Netflix, we have recommendations there. My research shows that over 1/3 of our choices on Amazon are influenced by algorithmic recommendations. Over 80% of the viewing activity on Netflix is driven by algorithmic recommendations. Beyond just product and media choices, you look at how dating is happening these days. You're using Tinder or Match.com. Oh, thank you very much. Tinder or Match.com, most of those matches are, again, algorithmically determined. It's there in the workplace, whether recruiters are using algorithms to screen resumes of job applicants, or bankers are using algorithms to decide which mortgage applications get approved. They're even making life and death decisions. In courtrooms in the US, judges are consulting algorithms before making sentencing and parole and bail decisions. Doctors are being asked to consult algorithms before making treatment decisions. So, they are as important as they can get in some ways.
Yeah, it's unavoidable. It's either the totality of the decision or certainly a critical part of the decision. So let's talk about how you've narrowed down your focus on algorithms with your new book. By way of background, I think it's Chris Anderson of Wired famously wrote a book about the long tail, where he posited, I think a lot of us believe this, that algorithms would actually democratize access to information. So no longer would it be a popularity contest of what we talk about. You'd actually be able to surface very niche topics and so forth. You in your research lab found out that that's actually not the case, though, which is the impetus for this. What was that moment, and have you told Chris Anderson he's wrong?
Yeah, so this goes back some time. So Chris Anderson he was a journalist at Wired at that time, editor-in-chief of Wired, and he wrote a book, The Long Tail, where he said how the internet will shift demand towards these niche items. We will discover indie songs, indie movies, and so on, and it won't be a blockbuster-driven culture. And I was talking about that in a classroom, and a student kind of posed this question of, is that really true? And, we did some simulations, and we found, maybe that's not the case. And then we did lots of empirical research, get data from different companies, to look at whether recommendation systems that were most popular at that time, like Amazon's people who bought this also bought this, or Netflix's people like you also like this. This is a type of algorithm known as a collaborative filter. We looked at whether they help shift demand to niche items, and we found they actually do the opposite. And this was a surprising finding, and they do the opposite because in order for something to get recommended, others have to be consuming it. People who bought this also bought this. People like you also bought this. Popularity is baked into it. And so our finding was that the most popular designs do the opposite. It doesn't mean algorithms have to do the opposite. In fact, over time, Amazon and many companies have changed the design of their algorithms to be able to explore more into the tail. And one of the things that going to music, for example, actually backing up Pandora did was, instead of people who bought this also bought this, Pandora's design was based on just going into the actual musical attributes and saying, what you seem to do is you like songs with a lot of instrumentation, you like songs that have a lot of rhythmic, what they call rhythmic syncopation, and we'll find other songs that are similar. There's no, the Music Genome Project. And so popularity is not baked into it, and so it frees itself from the popularity bias. But you have to collect all this information about the content. And I think what Spotify did more recently, they started with a collaborative filter, then they moved towards the Pandora-like design, and they combined it. So you get the social appeal of a collaborative filter, you're consuming what others are consuming, but it also bakes in the ability to explore that Pandora had. And not only is Spotify using that, Netflix uses that for movie recommendations today. So today's algorithms do not have that popularity bias. They do combine the best of both worlds, the ability to consume what your friends are consuming or people like you're consuming, but also the ability to go discover something that nobody else has found yet.
That makes sense. So harnessing the sort of intrinsic analogous or concentric value as well, whether it's a format or otherwise, as well as the extrinsic signals. That makes a lot of sense. You expectedly preempted the next question because we definitely did not rehearse this 20 minutes ago. But how are the, we did. How are the, you didn't know that though. How are the best or most impactful algorithms constructed? And I was wondering if you could spend time talking about the distinction between things like expert systems as well as machine learning. There's a lot of buzzwords out there, but you obviously have studied this and know how it's categorized properly.
Yeah, so I'm going to back up here before I answer your question. Just set up some basics, there might be some folks here who are not particularly into tech. So, if we talk about AI, what exactly is AI? AI is essentially how do you get computers to do the kinds of things that it takes human intelligence to do, like understand language or navigate the visual world, recognize people, manipulate objects, being able to reason, being able to learn, and so on. Now, the question is, if that's our goal, how do you build it? It used to be the case that for 30, 40 years, AI was mostly about interviewing experts and identify the rules they use to make decisions. So if I wanted to build an AI-based system to diagnose diseases, I would go interview lots of doctors and ask these doctors, how do you diagnose diseases? And the doctor tells me the rules. If the person has a cold but no fever, no body aches, I don't consider flu and influenza. But if they have a fever and body aches, I'm looking at flu and influenza. But if they've had the fever for over a week, then I rule out viral causes, I look at bacterial. So I code all these rules. It turns out you can build reasonably good AI using this approach, but it cannot match human beings. That's because there's a lot of knowledge we have that we are not able to express. It's an idea that Hungarian mathematician Polanyi refers to as tacit knowledge. There's knowledge we have that we simply don't know, we cannot express, right? So for example, if I asked all of you, I want to build a software that can recognize your mom in a photograph of many people. Give me the rules to recognize your mom. You can give me lots of rules. This is her shape of her nose. This is the color of her eyes. This is what her hair looks like. We could spend hours, and I can code all those rules. But that software will fail with the very first photograph it looks at, because you have tacit knowledge that you cannot convey. So where AI has gone in recent years, especially the last 10 years, is to say if people cannot give us the rules they use, people cannot share with us the knowledge, if we can observe them in action, maybe we can learn on our own. And that's the idea of machine learning. You collect a lot of data and you learn. So instead of asking doctors, give me the rules for diagnosis, if I can instead have data on 1 million patients who walked into a hospital, the exact symptoms they had when they walked into the hospital, the clinical markers, their blood test reports, and I know the final diagnosis by the doctor. Then I give it to a machine learning system and say, learn the patterns in the data. And it learns the patterns. Look, when the person has no fever, the person, these people are not diagnosing it as flu or influenza. If the person has that fever for a week, I never see a case where it's diagnosed as influenza and things like that, right? And so it does that. And you could apply this for anything, not just doctors. You want to drive cars? I can ask you what are the rules for driving, but trust me, that car is going to have an accident immediately. Or instead, I can attach cameras to your car in the front and the back and observe you driving for a year, and I can record this for 1,000 people and give this to a machine learning system, and it learns on its own what are the patterns. When does this person brake? When does this person change lanes? And it learns those patterns, and that's basically machine learning for you.
Would you mind distinguishing between expert systems and machine learning then?
Oh yeah, so what I just described was that distinction. Expert system is a series of rules. You interview experts and you find rules. So these are rule-based systems. Machine learning is not rule-based. Machine learning is give data, learn patterns in the data. And by the way, there are huge implications of that switch from expert systems to machine learning. Expert systems, by definition, are very predictable. You know the rules. You coded the rules. You know what the system will do if this happens and that happens. Machine learning, it's large quantities of data. And so you don't know what it's going to learn. And I mention in my book this idea of a resilience predictability paradox in algorithm design. And what I mean by that is you can either have algorithms that are highly predictable, like expert systems, but that are not highly resilient, because they'll encounter some new situation and they don't know what to do there and they fail. Or you have a machine learning system that just looks at tons of data and therefore knows how to respond to new situations. And even if it doesn't know, it learns from that and becomes better the next time. So highly resilient, but it's not highly predictable. And so that's a trade-off in AI design.
This is incidentally a great segue to the next question too, Professor. We are in Silicon Beach, as it were, which is everyone's favorite and worst name. But we all know what's going on Facebook. It sways elections. We all know what's happening with YouTube and brand safety. And there's this sort of proverbial challenge of, is the machine and the algorithm to blame, or is it the humans who built the algorithm to blame? So the question is twofold. One is, when is it the machine's fault and when is it the human's fault when something deleterious happens? And second, in what areas or capacities is there most unbalance or most opportunity for malfeasance?
Okay, so I'll answer the second question first, and then I'll come back to your first question.
The teacher will be the teacher.
So first I'll start with examples of what can go wrong, and then we'll talk about who's responsible for that. So examples of what can go wrong. Late last year, there was a news story that the Reuters put out that Amazon was using machine learning to do resume screening. Amazon hired 100,000 people last year, 100,000 people the year before. They probably got 1 million+ job applications. You can't have a recruiter sit and sift through that many applicants. So they wanted to use machine learning to improve that and automate that process. What that Reuters story reported is that Amazon created a system that had a big gender bias, and they could not rid that system of gender bias, and they shelved that project, is what the news report said. In 2016, ProPublica did an analysis of algorithms used in courtrooms in Florida, and they found that the algorithms that are guiding judges on how to do sentencing and parole, they had a race bias. They were twice as likely to falsely predict future criminality in a black defendant than a white defendant. We've heard of the Facebook fake news problem. The backdrop there was Facebook had human editors curating the trending news stories. These human editors were accused of having a political bias, that they were left-leaning. So they said algorithms cannot have a political bias. They rolled it out, but it couldn't detect fake news stories. We had the Boeing air crash last week, and you look into it, ultimately, it's the automation that has a problem, and humans did not know how to take over when the automation. So there's many examples, and I just mentioned a few. There's My book lists many more, and there's many more I just didn't list because of lack of space. So there's many examples of algorithm failures. Who's responsible for that depends on whether this is heavily rule-based or is this machine learning. If it's heavily rule-based, it's the programmer. If it's heavily machine learning, it's the data. And in fact, in trying to figure out who's responsible, one of the insights I had was, algorithm behavior is not unlike human behavior. With human behavior, psychologists bring down our behavior to nature and nurture. Right? Nature is our genetic code, what we inherited from our parents. Nurture is our environment, our parents and friends, and what influences they have. Actually, I once heard this: nature or nurture, either way, your parents are to blame. Right?
There's actually a lot of evidence that corroborates that.
Maybe. Yeah, in this case, so machines have nature and nurture too. Nature is the code that the programmer gives it. The rules the programmer programs and codes in. Nurture is the data from which they learn, right? And so here again, when machines go wrong, it's either their nature or their nurture. It used to be the case that machines were all nature, no nurture 15 years back. Today, they're becoming more and more nurture. And so when you see Amazon's resume screening algorithm has a gender bias, that's because that system, you've not programmed the rules. You've instead said, here's data on all our job applicants. Here's who got hired. Here's who got promoted. Now find more people like them. So if there's a gender bias in the organization, that will be picked up by the system. Same thing with the algorithms in courtrooms in the US. If it turns out that there's a race bias in the criminal justice system, it will pick up that bias as well. So I think I gave a long answer to your question, but I did answer both, I think.
You did. Let's go another step further. So whether in the rule side or the machine learning side, are there consistencies or types of categories where there's most imbalance? So said another way, in all the anecdotes that you mentioned, are there consistencies in whether the way the rule is, whether the way the rule works, or the type of industry it's in, or I don't know, or maybe there's always a victim. Like, what's the rule that makes this most imbalanced? Yeah.
So here's the way I think of it. When you had systems that were primarily rule-based, these systems were not highly capable. So you could deploy these systems in fairly simple settings. You couldn't do ambitious things with it, right? And so you can, for example, create software that can do our taxes because it's a simple set of rules on how to do the taxes. You want to drive cars. You want to, do resume screening. You want to do the kinds of things that it requires human intelligence. You want to do machine learning. And so what's happening now is the more ambitious things we are tackling through machine learning, it's almost always the data. And so the big problems that we are hearing about, it's usually the data. It's usually that you've learned, you've thrown large data sets at the problem, and you can't curate that kind of data, and you're running into these kinds of issues.
Got it. So it's not just the parent, it's the data that's the issue.
It's mostly the data, and of course you could ask, where's the data coming from? The data is coming from human decisions, and so ultimately humans are responsible, but it's not so much the programmer, but it's the way we all make decisions. We all have subconscious biases. So, people think algorithms are objective, rational decision makers, but they're capable of the same subjectivity humans have because they're learning from the data that is generated from human decisions.
Well, that's a very circle of life of you, Professor. So I thought in my peon brain there are actually two steps. So there's the rules that are expert driven or human driven, and then there's the machine learning that adapts, assuming it's sophisticated enough. But there's actually a third piece, which is actually where the fallacy comes in, which is sort of human biases themselves. All right, so humans are to blame. Cool, makes sense. All right, I was wondering, I think it'll be relevant. When have we made mistakes, particularly on the rules side, in making meaningful algorithms? And is there consistency in those mistakes? And I'm wondering if you can speak to this through the shall I's versus the Tay anecdote. Omid flagged this. I thought it was quite interesting.
Yeah, so I opened the book with a story about...
Spoiler.
Yeah, I'll reveal it.
Everyone dies in the end. There's a snap.
No, I will reveal the start of the book, but I will not reveal the end of the book.
There's a snap.
In this talk. So in the book, I talked about this person I interviewed as part of my research. Her name is Chen, who is a 22-year-old in Shenzhen, China. And her daily routine involves chatting with a social media celebrity in China called Xiaobing. And it's daily conversations with a celebrity who has 40 million followers. And a quarter of these followers have said, "I love you" to Xiaobing. And it's really interesting that a social media celebrity can have this level of personalized one-to-one interactions with fans. And a quarter of them have said, "I love you." Of course, as you dig into it, you realize Xiaobing is not a human being. Xiaobing is a chatbot that was created by Microsoft in the persona of a teenage girl who chats and engages in fun, playful conversations. Now, Microsoft observed the success of Xiaobing and said, let's replicate that in the US. So they created a chatbot to chat with people, again, persona of a young teenager who engages in fun, playful conversations with young adults and teenagers, and launched that on Twitter. Within 1 hour, that chatbot turned sexist, racist, fascist, and said all kinds of things like Hitler was right and feminists should burn in hell. This was 2 years back. It was called Microsoft Tay. Many of you have heard of it. And they shut down the project within 24 hours. And it led me to ask this question: how is it possible that two chatbots created by the same company using the exact same approach can have such different outcomes? And so I started digging into it. And it turns out there is some rule-based aspect to it, and then there is a lot of nurture data in there as well. The rule-based aspect was in China, they had a bunch of rules in addition to the machine learning, in addition to giving it lots of data and saying, learn how to talk like this. They put in a bunch of rules. You cannot say this, you cannot say that, you cannot. I think some of this may be cultural. In China, they're used to putting a bunch of rules in terms of how they can talk on social media. And so there were these rules. In the US, they didn't put some of these rules. Secondly, the issue is also data. Anyone who spent some time on Twitter knows Twitter is not where you learn how to converse with people. And it was,
you learn how to argue, though.
Maybe, yes. And so that's what it did. It was given a lot of data from Twitter and say, tweet like this. And furthermore, it was told to emphasize the more recent tweets. And so people started trying to see, can I trip Tay? And they're saying sexist, racist, fascist things to Tay. And Tay learns, oh, this is how you converse on Twitter. And so it starts saying these things. And so that's an example of how you need to be careful about both the rule part, but especially about the data part.
So that begs the question, there's no panacea for this, but across the three tranches, so on the rules and machine learning side, as well as just the way we're raised, I guess, and the data that we input, how do you control these algorithms?
Yeah, so in the book, I have this idea of what I call an algorithmic bill of rights. And
it's there.
Okay. It doesn't agree. No, that was something the sound person and I discussed in advance. That was a timed sound to let you know I'm saying something important, so pay attention now. So one of the things I say is, look, I think the stakes are very high in terms of us automating so many of our decisions. And we need to have lots of checks and balances in place. And in order to make sure this doesn't go out of control, consumers, firms, and the government all have an important role to play. And so I talk about what consumers have to do, what firms have to do, and what governments have to do. I won't go into all of the details here, but I will say there are some basic principles that I advocate. One of those is the idea of transparency. And it's the idea that, first of all, we should be informed when an algorithm is making a decision. Half the time, we don't even know that a decision was automated. We should be informed what is the data being used to make the decision. We should be informed about what are the key factors the machine kind of weighs in sort of making those decisions. And that transparency is important, not in every algorithm, but in algorithms that make socially consequential decisions like recruiting or loan approvals or news curation and so on. Interestingly, Mark Zuckerberg wrote an op-ed this week in Washington Post saying that we need global regulation of the internet, and one of the things he argued for was transparency. And it's really interesting, you know, I was writing this 1 year back, and I never thought Mark Zuckerberg would argue for this, and he's kind of proposed this. So even tech companies are open to certain ideas in regulation, light regulation, some of these ideas that I mentioned. Another one that I mentioned is related to what ZEFR does. I kind of argue for human in the loop. So I talk about users should have some control over how algorithms make decisions for them. A lot of engineers focus, excuse me, on full automation. The idea of the engineer in many instances is let's automate the system as much as possible, make it fully autonomous so users don't have to do much. And so that's a great user experience. I think you do that, you end up with problems. So I kind of say, look, there should be a human in the loop. Look at Facebook's fake news issue, for example. 2 years back, lots of people observed that they're seeing fake news in their newsfeed. They observed it and they ignored it, but they couldn't prevent the algorithm from circulating that to their friends. They couldn't even inform the algorithm, hey, stop showing this kind of stuff. Facebook realized the issue, and today, with 2 clicks, you can highlight content and say this is fake or this is offensive. That's a human in the loop. And so make sure there's a way for humans to influence how the algorithm works. There was this issue with the terror attack in New Zealand where the algorithms at Facebook could not detect that the content was circulated. A lot of media focused on, hey, your Facebook's algorithms doesn't work, they don't work, and it's getting circulated. But I think the interesting story there is also a lot of people realized it, they flagged it, and the algorithm was in, I think, 15, 20 minutes, able to realize so many people are flagging this as offensive, alerted a human who then kind of got in and said, okay, this is taken off, right? So I think the human in the loop is important. Another idea is auditing the algorithms. And I kind of say, look, if you're deploying algorithms in socially critical settings, you should have an audit process for algorithms. And you should have algorithms audited by a team that is independent of the team that developed the algorithm. And so that level of independence is important. These are few ideas. There's many more. I'm not going to tell you everything because you have to read the book.
Can you, without seeming too Terminator disaster-like, so a lot of these solutions are I guess, incumbent on whether companies and governments change these things, and we all know how quickly that goes. What can consumers at a practical level do? What should I share? What should I not share?
When you share, you're talking social media?
I like rom-coms?
Sorry?
Should I tell Netflix I like rom-coms?
Well, so in terms of what can consumers do, I think a lot of people feel that you're helpless against big tech, right? There's nothing we can do. I think we do have some power, and we underestimate the power. It's obvious stuff, knowledge, dollars, votes, things like that. Knowledge is just about, let's not be passive users of technology. Let's understand how technology is changing the choices we make or others make about us. And that's crucial. I mean, look at, for example, how Facebook announced that they're going to encrypt their messages. They're going to allow messages to disappear if users want them to disappear and so on. Why did Facebook, a company that not too long ago said, look, privacy is dead this, in this era? It's because users push back. And so I think knowledge and activism is important. Votes matter. I think, how many of us can name, when we're looking at elected representatives, who's actually savvy about these issues? I think we need to understand what are their views about this. I think this is the first election where we'll see candidates actually showcase their ideas on big tech regulation. We've already seen we've already seen some of them do that, right? Senator Wharton made big announcements. I personally don't think her solutions are right, but she picked the right set of problems to look at. And so I think we'll see lots of candidates do that. So we should look at what are their ideas here. And I think it's important for lay people to get educated about what are the problems here so we can evaluate the proposal. So I actually wrote a New York Times op-ed last week, which was called Citizens Guide to Big Tech Regulation, where I didn't advocate any viewpoint on how we should regulate tech. And I actually, I was surprised New York Times was willing to do this. I said, I have an op-ed I want to submit where I have no opinion. And I just want to do an educational piece where I want to let people know what are the problems and help him understand the problems. And I just raised, here are the problems with consumer protection, here are the problems with anti-competitive practices, here are the problems with algorithmic decision making. So I think it's knowledge, votes, dollars. Again, when consumers kind of say, you can't have my money, firms take action. When consumers start installing ad blockers, the ad companies say, okay, we need to pay attention. And now you have all ad companies kind of coming together, creating initiatives about what are good advertising practices. There's an initiative called LEAN, Light Encrypted Ad Choice Non-Invasive, which ad companies are pushing so that ads comply with certain basic things that we want. Why are they doing this? Because almost everyone under age 30 has ad blockers installed in their browsers. And so they're forced to do this. So I think there's a lot we can do.
Fair enough. I'm going to jump to the last question in the interest of time. This is completely selfish. From your emerging technologies course, what are the biggest tech trends that you're tracking right now, and how do you think they're going to evolve in a few minutes?
So biggest tech trends, I think one clearly, and I wrote the book on, not the book, a book on it, which is AI, right? So I really believe that the potential here is phenomenal, and this is not a 100-year thing, this is not a 1,000-year thing, this is exponential change in AI capabilities, and in our lifetime, we're going to see amazing things happen with AI-based systems. And so AI clearly is one that I'm sort of looking at quite closely.
And what in AI do you think is going to evolve the most rapidly soonest versus what do you think is overhyped? Sort of like in entertainment, the answer is VR. VR, so we're still several years away.
Right. Yeah. So VR clearly, I'm not super excited there. But if you look at AI, I think some of the most interesting things where tech can get there super fast, can regulation catch there super fast is a question. So driverless cars, right? There's a Chinese company called Jingqi, which got started in January of 2017. By July of 2017, they already had cars driving in Sunnyvale in completely driverless mode. In 6 months, they went from having no code to having a car driving around. That's the, sorry? No, they were doing it here. But they are doing a lot in China as well. I spoke to the team here. Yeah, I think, yeah. No, but they have cars driving around in China as well. So driverless cars is one. Smart cities, and so that's where two interesting trends intersect, AI and the Internet of Things. And so I think, again, if you look at industrial IoT, where you have smart sensors that are collecting data that can automate lots of decisions. So I think the intersection of AI and IoT, again, technology is moving quite rapidly over there. So these are some areas. There's going to be, lots of change.
Fair enough. Let's go to questions. If you ask a question, you have to buy his book. That's how this game works.
I didn't bring any books, sorry guys, but
all right.
Yes, but if you ask a question, you buy the book. If I answer it well, you write a review on the book.
There you go.
Before we start, let's just give him a round of applause for Professor and Bing. Thank you. Thank both of you. Okay, start in the back.
So it was interesting that kind of the loop you said about. It was interesting about the machine versus the human and the biases that the machine data picked up on, which was picking up on the inherent biases that humans have. So earlier you also talked about how the collaborative, the popularity of Netflix and everyone else. So if we start to see that with human in the loop, is there a way to identify the biases in areas or companies or processes?
Yes, I do think, by the way, something we didn't get into, and before I answer your question, I want to say that there's a lot, sorry? Yeah, I don't want to reveal too much, but I'm going to say this anyway because I think it's really important. I see a lot of fear-mongering about AI and algorithms and so on, and there's a book called Algorithms of Oppression, and there's a book called Weapons of Math Destruction, and there's a lot of fear here. And I think there is a legitimate cause for concern, And I'm not going to sort of say we shouldn't be worried. Actually, most of our discussion, I've made the case, look, we should be worried here. But I think there's two factors that we have to keep in mind. The first, there's a lot of evidence for this, which is that algorithms on average are less biased than humans, on average. The problem, however, is that when algorithms do get biased, two things happen. There's a feedback loop. They pick up bias, they make biased decisions, they learn from that bias, they make biased decision, and it can go out of control. Secondly, algorithm decisions scale the way human decisions cannot. A biased judge can affect 500 lives. A biased algorithm that's used in courtrooms all over the US can affect millions of lives, right? So the scale is the problem. And so the question, so I think we should indeed worry about it, but I don't think we should become skeptics of algorithms or AI. I think there's a lot of great potential here. The question is, can we fix it? And I absolutely believe we can fix it. And your question was about how do we detect it and so on. And one of the things I've been pushing a lot in my talks with companies, even today, I had a talk at Snap. And one of the things I was talking to about their data, I had a personal discussion with the data governance person was that you need to have an audit process about as far as algorithms are concerned. The way audits, first of all, there's no audit of algorithms. The way algorithms are tested and rolled out is that you have a golden metric you're looking at, like say prediction accuracy or some technical metric. And you find an algorithm that beats it and then, or that does well at it, and you roll it out. And so I kind of say that's not enough. Evaluation of algorithms have to go beyond technical metrics like accuracy and have to incorporate things like fairness, have to incorporate things like transparency. Can you explain the decisions of the algorithm? Have to incorporate things like privacy implications of the algorithms. They have to look at security implications. You have to have a holistic assessment, and that has to be part of the audit process. So I do think these can be tested for. You just have to build a process around it.
That feels like a two-book answer.
That's right, that's right. Yeah, Amazon discovered a lot about their own organization, and I guess clearly this brings in broader changes at the company. But they did the audit, and Amazon, to their credit, is a tech-savvy company that understands the issues and tested for it. How many companies are testing for this? Almost no one. And there's many companies using algorithms for resume screening.
So I just wanted to go a little bit deeper in that and then ask a separate question. The separate question is going to be about where neural networks play into all this stuff. Is that in a subcategory of machine learning, or is that in AI and everything? But just relative to his question, even with a human in the loop, that specific human still potentially has biases. So even though it may be fewer overall, how do you ever get to a point where there are no more human biases within the answers you get?
Yeah, look, so I think if we subject algorithms to the standard that they have to be perfect and error-free, we will never get there and we will never use them. I think we have to ask, can we get much better than humans? I think the standard for algorithms have to be much higher than the standard for humans. Because, like I said, algorithms can touch millions of lives as opposed to a biased human touching hundreds of lives. So the standard has to be higher. But it cannot be that it has to be 100% accurate. There's 100 things we can do. We talked about human in the loop, but that's not the only thing you do. You have an audit process as well. That will catch a bunch of things. Human in the loop will catch a bunch of things. Transparency will catch a bunch of things because now you have to explain your algorithms. Even these black box algorithms that are becoming very popular, that are very hard to explain, you have to interpret them. And so all of that will help. I think when we say, we don't want to use algorithms, I think we have to ask, what is the alternative? And the alternative is humans, And boy, do we know that they have problems, right? I mean, we want to say, should we use driverless cars? Yes, we should ask how safe are they. But what is the alternative if we don't use them? The alternative is drunk driving, people texting while driving, and all of these things, and most accidents are human created. So while there's an ethical question about AI, there's also a meta-ethical question, which is what is the cost of not using AI? So I think we've got to balance both of those.
My question was, you talked about that Microsoft study, and it didn't work in the United States because they fed in the data was Twitter. So, and we know all about Twitter. How do you, for that type of study, for example, with diagnoses, that's more objective. The data you can get over, looking at thousands and even thousands of data of the way doctors make a diagnosis, but this is more communication. So what kind of data, or how do you process data, and would you be manipulating data, which would then create a bias? How would you, what kind of data could you use for a fair communication? Because communication is much more ambiguous than diagnosis.
Yeah. So by the way, even in a diagnosis setting, you run into different kinds of issues. So for example, what was the training data set? There have been studies that showed that, some of these AI systems struggled with detecting and also coming up with the right treatment options for minorities because, again, the training data set was a certain type and they didn't know how to adapt to that environment. There's also other issues largely related to the data. But again, coming back to your question of, conversation, it's so unstructured, how do you control it? I think the way you control it is, again, through audits. You have rigorous testing where you test for many kinds of things, but you also have rules in place. You put rules in place that prevent the machine to go. Microsoft actually released a subsequent chatbot. That subsequent chatbot was not allowed to discuss certain topics. And you put certain rules in place. Lots of companies are using chatbots today on their websites to chat with customers. Guess what? And we've seen it, these chatbots are very basic in capability. They're not machine learning based. They have simple rules that govern how they talk because most of these companies are worried about unleashing a completely machine learned system to chat with customers. And so there's mostly rules about if this is the kind of question, you can share this kind of answer. If it's that, you share that kind of answer. It cannot have a real conversation with you. So it's mostly about putting rules. You think about a driverless car and you're worried, hey, it might do crazy things. What you do, what Uber does, is the motion planning system, meaning the system that determines all the rules for driving, like when to change lanes, when to speed, when to slow down. It's a machine learning system, but above that, there's also a rule-based system. And so you have to keep these in mind because there's lots of possibilities here. One of the things you talked about is people intentionally trying to trip it. There was a study that showed that most of these driverless cars, if you just put a posted sign on a stop sign, they cannot detect the stop sign. That's because they're trained on a data set where no stop sign had a posted note. And so they expect stop signs to look a certain way. So if somebody wanted to imagine there are driverless cars all around, somebody wanted to create havoc, you put graffiti on the stop signs and these cars get confused. And of course, the Uber and Google, they realize that now. So they add rules in there. They say there is supposed to be a stop sign here. We know it, and that's a rule. Even if you don't detect the stop sign, you have to stop here. So you add rules, you kind of, build in the rule, the nature in there as well.
Thanks. So you've talked about audits and kind of transparency as a way to track how algorithms are doing, but those tend to be internally focused within a company. Is there any sort of independent organization that's looking at algorithms and rating them? And if not, what's your take on kind of a consumer reports for algorithms, like someone that goes out there and just independently rates if they're actually, good or bad?
Yes, so I do think that's a good idea. I've been doing some work on not exactly that, but a related idea, which is actually on auditing these algorithms for companies and so on. Yeah, I think there is an opportunity for even consumer reports for all the algorithms around us and an evaluation on various dimensions like privacy, security, and many other things, bias, and so on. So yeah, there's I think many things that we could be doing here. I think we're all just waking up to the possibilities over here. It's going to be a very interesting space, I think.
A couple more questions.
I have a question for either of you, your student, your master. I think there's a small generational difference between you, and it's about that. I'm a little older, and I didn't grow up with many of these things the way my kids did. And I noticed, for example, that when I have ads pop up, I just bought a jacket from Macy's online, and now I'm flooded with, it irritates me, that's because it's irritating, but also it just irritates me. It's kind of dumb. First of all, I just bought a jacket. Why don't you advertise a shirt? It's so elementary. But more than that, it just bugs me that you're intruding. Or let's say on Netflix, all the recommendations. I make a point of not going to what they think I want, just because maybe I'm old and cranky. But I think my kids, our kids, have grown up with that. They're more comfortable. Maybe there are also less expectation of privacy. This is sort of a privacy thing here, invading my own decision making, not stealing my data. So why do I ask about generational differences when it comes to these big questions in the future, such as lethal autonomous weapon systems? Do you think that the concerns, the ethical concerns that might be uppermost now will be less? The younger generation more willing to look at it, why do we need a human in the loop when humans make all these mistakes? Maybe really good algorithms and sensors will actually be much safer in patrolling or policing. To some of the older generation, it's just abhorrent. There has to be a human there. But the data might show otherwise, and maybe the younger generation will make decisions very differently. So it's a generational psychological question. Sorry so long.
Yeah. Do you want me to tackle that first? You have something to add, I'm sure.
You know the youth, Professor.
Well, many things in response to that. As I mentioned, for example, first of all, there are obvious generational differences. So everything you said about there being generational differences is true. The second thing is it's also evolving. So I used to ask students, and I've asked this for at least 10, 15 years, students' views on privacy. And over the years, it's evolved. And for some time, I used to think, I agree with Mark Zuckerberg that privacy is dead. Students don't seem to care about it. Last 2 years, that has changed. The students are suddenly asking for a lot more, and my casual, informal survey, the results seem to be very different. And also, I think they're savvy about how to protect themselves. I mentioned how, and I've run this survey every year for the last several years. I asked my undergrad, my MBA, and my exec MBA students, how many of you have installed a browser plugin that blocks ads? And it's a clear generational difference. Among my exec MBA students who are in their 30s usually, it's maybe 20, 25% who've installed that plugin. Among my MBA students, these days it's maybe about 35, 40, 50%. Among my undergrads, it's like 80%. So I think, I think they're also responding to these problems in different ways. They're equally frustrated like you, and they're kind of saying, I know how to get past it. So I think there's all of these things in place. I read the story, now this doesn't scale, but I read the story about this guy in San Fran, a techie, who actually created his own app to randomize some of his decisions. He realized how much of his world was curated by the technology around him. So he created an app, and he did simple things, like he's calling an Uber to take a ride. He goes through his app, which calls the Uber, but his app randomizes the pickup location to be within, a half a mile or a quarter mile of his home. So he has to walk out and go experience the world and not get the Uber there. He does other things in there as well. He wants to go for an event during the weekend. His app looks at all of the events on Facebook that are listed and randomly picks an event, and he has to go there. And he mentions in that story that there was some Russians in Bay Area kind of get together within this Russian community where everyone seemed to know each other, and he randomly showed up there. And he said he thought it would be awkward, but he explained to people, well, this is why I'm here. And they said, okay, fine, come join us. And he said he's added serendipity to his life through that. So I think people are doing some interesting things. I don't know where we'll end up. But yeah, so I mean.
What's the app called? It's your new screenplay.
So it's an interesting screenplay. It's an NPR story. Yeah, it's an NPR story. If you just look up NPR and the guy who randomized his life, you'll find this guy.
Couple more questions. Professor, how many more do you think? 2, 3?
It's up to you. Oh, I do have a flight.
We got an 8:30 hard stop, so I'm going to try.
Yeah,
to get,
8:30. Let's shoot for ending at 8:30.
So
What is the time now?
It is 8 o'clock, but we got to
Oh, okay.
clean up. So maybe 10, 15 more minutes. Okay, so we'll try to get everyone.
Okay, on Bloomberg today, there was a news topic. It didn't say anything about it. It said Google has disbanded its AI ethics committee because employees are protesting. What's the hope?
I have to read this news story, and I think also a lot of these news stories, I dig into it and I find out the headlines are often very misleading. What I do know is both Google and Facebook and many other companies have reduced the size of their AI teams in the last 2-3 months. Yes, and I know Facebook also had some such thing. I would personally doubt that Google is doing exactly what that report is suggesting. I don't know if I'm not saying it's fake news, but there's more to it than that. I'll dig into it. I haven't seen this news story. I've been in nonstop talks since yesterday, but I'll dig into it. But I know they have reduced the size of their AI teams across all of the AI divisions because they were very aggressive in recruiting into their AI teams and paying people $2-3 million to join their AI teams and more. Do they have diversity in their AI teams? It's an interesting question. They are doing a lot to bring in diversity, but it's not there because, the supply is not there in terms of, they wanted to have more, you were at Google, this problem. So the supply is the part of the problem, but the company is doing a lot in trying to make sure there's diversity. But I think just having diversity on your team, while it's a good goal and it's a must-have, is not going to solve this problem. And many people say that, hey, you should have a diverse team because, hey, if you have a diverse team, you will detect these kinds of issues. And yes, it's partly true, but not completely true because with lots of companies, the AI teams are actually quite small because there's so much automation. You don't need several dozen people with lots of companies, and I don't mean Google, but with smaller companies, your AI team is 3-4 people. How do you have diversity in terms of gender, race, sexual orientation, nationality, and I don't know, you can pick so many dimensions, all of them in a 4-person team. So that's why I feel like, okay, great to have diversity, go for it, but don't treat that as the solution. You need to have audits in place, you need to have formal checks and balances in place.
Hi, I'd like to know a little bit more about Waze and kind of the map apps, and I think this might be relevant to a lot of us here. I live parallel to a really busy street, and something that I've been doing is about 15 minutes before I leave, around rush hour, I've noticed that so many cars are being diverted to my street, so I go out onto the curbside and just drop all sorts of accidents and police sightings and whatnot. And then 15 minutes later, when I leave, it's completely empty.
You should also.
And I've told my neighbors this, and then they're all starting to do this. So, it works, but I'm worried if the Google Maps apps or the Waze apps, are they smart enough to catch on to my behavior?
No, you're serious, right? You actually do this? Wow, okay. Yeah, that is another screenplay, no doubt. I don't even know how to respond to that. Yeah. Yeah. I mean, the way Waze works is, again, it's real-time data from others using the apps on where they are, and so it figures out traffic based on that. And if you put those signs in there, it's seeing people are avoiding it even though it asks them to go that way, and then it says there's some problem there and I'm not going to avoid it. And then at some point when you remove your sign or you don't do it and they start to see people going there, it adapts, and so it does respond to all of that. Will they detect you're doing this? I don't know, If more people start doing what you're saying, so don't reveal it publicly. If more people start doing this, then they will start, trying to catch this kind of behavior. It's your dirty little secret. Keep it to yourself. Yeah.
Tonight we spoke a lot about having a lot of auditing within the process of machine learning. And so my team, we're building like this huge machine learning project. And what we've learned over time and what concerns the team a lot is all these open source projects, they do like a lot of importance weighting. So for the audience, if you guys don't know what open source is, it's basically a developer publicly sharing their code, so you don't have to do it yourself, which means if you're in the desert and you're a company trying to do machine learning and the code is a water bottle, you're probably going to drink it. And here, the auditing process is probably a filter on the water. But because machine learning is such a hot thing, everyone's drinking the water. And what concerns me a lot is that a lot of startups are building a lot of projects using these open source libraries. In your research and in just your opinion, how do you think we can address this?
Yeah, so the question is, again, just to recap, there's a lot of, instead of starting building your machine learning from scratch, why not take an open source code and build off of it, right? If you want to create machine learning for image recognition, you don't have to start from scratch. You go download an image recognition source code that Google has released or somebody's released and you use it. And of course, if there's problems there, it's not only the source code that's available, there's increasingly marketplaces for data as well. So you want image recognition data, you can download data sets that have people's faces and names and so on, and you can use those and so on. So I kind of think, one interesting thing is going back to what was mentioned earlier, I think if we are going to do more and more of these open source algorithms and or data, we should start rating these things as well. And so I think that's a really interesting thing to do. So I think you could do public audits of the open source systems. At least that's one solution I can think of. I'm going back to audit, so you've clearly seen what's my favorite solution, but that's one of many.
I don't mean to sound flippant, but I struggle a little bit with the difference between what you're describing and just an expansion of statistics writ large by increases in computational power or the ability to have a digital interaction where 20 or 30 years ago, I feel like you would have heard similar conversations questioning the use of statistics, just the ones that I learned how to do, in college, versus, because I guess I don't know the difference between what you describe as an algorithm and what is just application of statistics by a computer. And so I don't know exactly what the difference is.
Okay, so what's the difference between everything we're talking about and just plain old statistics that's been around for a while, right? That's a good question. I'll give you the technical answer and then I'll clarify what I mean by that. And for those of you who are data scientists, you'll get it. One way to think about machine learning is it's statistics without standard errors. And so I'll clarify what I mean by that. So statistics, at least the way we use it, mostly is about hypothesis testing, right? You have a hypothesis, you formally test the hypothesis, and you get an estimate. Let's say you wanted to predict what will be this person's, I'm making it up, likelihood that they will pay back their loan on time. And I have certain hypotheses. It depends on their credit score. It depends on their income. It depends on their education. And I have data and I formally test the hypothesis and it says, yes, income matters. Yes, education matters. And here's how much it matters. And I get all of that. And I get precise estimates and I also get the errors. How likely is it that we are wrong? So you're able to do hypothesis testing. Machine learning is not about hypothesis testing. It's about curve fitting for the most part. Help me predict the best. It could be causal, it need not be causal. There could be spurious patterns that could mislead me, but I'm just predicting well. So you're not doing hypothesis testing, you're not testing theories there, you're just doing better job at prediction. And so sometimes spurious correlations can help you predict really well. It depends on what you do based on the prediction, because are you assuming you know the theory and making actions based on saying I understood the theory? The other way to think about it is that a lot of statistics, you have y variables. I mean, all of statistics, you have a y variable and a set of x variables, right? The x is trying to predict the y. You look at modern machine learning approaches like neural nets, you have no x variable. You're saying, I don't know the x variables. Here's the data set, figure it out. You want to figure out how to recognize people's faces. The old way to do this is to say, here are rules. Look at their nose, look at their eyes, look at this, look at the color of this, and you put in those rules. Those are the x variables. That's the old way of doing it. A neural net is saying, here are photographs, figure out the patterns. I have no hypothesis. And so you don't have to do figuring out the x variables with things like neural networks. So it's a hypothesis-free way of predicting.
Here I am. It's kind of a simple question, but where do you think machine learning will fail? And from some readings, obviously, at this point, they're still having issues with doing emotions. You know, how do people emote and, you know, managing that in machine learning?
Okay, there was some background noise. I want to confirm. I think you asked, where do you think machine learning will fail and can it handle things like emotions, right?
Well,
Okay.
I think that's one of the areas where they're suggesting right now is probably the weakest link.
Yeah, so where will machine learning fail? We can talk about lots of failures today, but where will it fail 10 years from now, 20 years from now? And I think that list is going to get smaller and smaller and smaller. And things like, can machines detect emotions? Yes. There's already evidence that they can detect the obvious emotions, but even subtle stuff, yes, they can. Or rather, yes, they will. And they're getting better at face recognition, understanding what is going on. It's about, can you collect the data? Can you observe people's faces and ask them and truly figure out what they were feeling? And if you can get that kind of data, then it's able to figure out, okay, when people's faces turn this way and that way, this is what is going on. So I think we will get there, even with things like emotions. So, yeah, I mean, I'm kind of indirectly hinting at, can machines eventually be as generally intelligent as human beings and not just good at specific tasks? That's what today's machine learning does. Give it a task and it can get good at it. Can we get general intelligence? I do believe we'll get there. Whoever has the mic, I'm not controlling this.
Yes.
Yeah.
My question is about use of the machine learning on innovation and creative space. So the Amazon's gender bias example reminded me of the criticisms on House of Cards, how you can look back what people already like and debone the attributes and apply, but you kind of get stuck into the loop. So can AI and machine learning be used to come up with something really brand new?
Few anecdotes to answer your question. First of all, if you're using data to learn, you're going to learn only what you've seen before, right? And so that's a limitation of a certain kind of machine learning, which is the dominant form of machine learning today. That's supervised machine learning, meaning you get training data and you learn from it. But even with that, people have done some incredible things, like compose music, have an AI system compose music, have an AI system paint, like there have been studies where I forget which artist, was it Rembrandt? Look at all of Rembrandt's painting and paint something new like Rembrandt, and have an art critic look at that and tell, is this a Rembrandt original? And it passes those tests. And so yes, AI is being used for creative things. IBM Watson created a trailer for an AI movie. And if you go to YouTube and search for IBM Watson AI trailer, you will see it. And when I looked at the trailer, it was for a horror movie, and I was genuinely scared. It didn't look like a stupid trailer. So it was genuine. But again, the system is looking at lots of data on trailers in the past and creating trailers like that. So I think the leg up we will have against machine learning over the next several years and maybe decades is the ability to do something nobody's thought of. Having said that, there is another form of machine learning known as reinforcement learning. And that is essentially machine learning where the AI creates its own data rather than looking at data. So it tries something new, and it observes what happens, and it sees, did this work or not, and then it learns from that. And it tries something new, and it learns from that. Google's DeepMind built a game-playing system called AlphaZero. AlphaZero because it had zero training data set. So it just played a bunch of chess games against itself, a bunch of Go games against itself, and it could beat everything, including the best supervised machine learning algorithm. Today, people are trying to see, can you use this in drug discovery? Because drug discovery is all about trying millions of molecules against something and seeing which ones seem to be working. And when you see something is working, you then try variants around that. That is basically reinforcement learning. You explore, you try something. If it fails, you discard that. You try something. The moment something works, you explore around it. So you want to do paintings, you create a reinforcement learning algorithm that initially makes crazy, stupid paintings. People will say, this is stupid, we don't like it. And it just observes. And it says, hey, people seem to like when I try these kinds of explorations, and it learns that. So eventually, we will have AI that can be creative as well.
Okay, I know there's a lot of questions. We have time for maybe two more, and then we got to wrap up.
I was hoping you could speak to the Bill of Rights that you discussed earlier for algorithms, and I think of this in the sense of the chatbot that you brought up. In the country that you did, how do we allow for this Bill of Rights not to become a form of censorship and have the opposite happen?
Yeah, so tough question. So first of all, in terms of what's in the Bill of Rights, I have things like I mentioned transparency, I mentioned user control, I mentioned, again, the responsibility of the firm to educate the user, the responsibility of the user to educate themselves, audits and things like that. So that's what I have in the Bill of Rights. Essentially, it's about giving users more control. In fact, the reason I call it Bill of Rights, the history is, of course, from the US Constitution. And the history is that when the founding fathers were creating the Constitution, they were worried that they're creating a federal government that's way too powerful. They were worried that you're going from one form of tyranny to the other. So they said, let's give citizens some rights so that the government cannot be too powerful. So it is indeed in that spirit, you're kind of saying, how do you make sure the end user has power? So how do you prevent state-controlled abuse of this? Well, if a state follows the Bill of Rights, then the state cannot abuse it because consumers have the rights. But does the state have to follow it? State-controlled and state-managed abuse of AI is going to be incredibly hard to manage. We know in China there's the citizen scoring system that's already in there that's monitoring citizens and scoring them. Any amount of principles I provide, ultimately, if the state is not following it, you can't do much. The only way you deal with these kinds of things is you have states coming together and have global standards, and you take action on countries that seem to violate certain things. You have human rights standards, you have nuclear weapon use standards that are globally agreed on. You need similar things as well for something like this.
Okay, last question. Let's go here.
I believe you said early on that you were surprised that popularity did not play as big a part in decision-making as you thought it might. Am I correct? Did I understand you correctly?
So it's the opposite. In the original designs,
Yes.
Because they recommended movies and products based on what others are consuming, they tended to have a popularity bias.
Okay.
Okay.
No question?
There was that
Okay,
gentleman
one more,
who's had
yeah.
his hand up for a long time. I feel we should end with his question.
Last one.
So my question is about the ProPublica, the parole software,
Yeah.
which was like thought to be biased against like African Americans. There was like some discussion after that critique that there was really no good measure of fairness there because if they were wanting to have like correct predictions across the races, the false positives would always be skewed. So like if there are algorithms which like fairness is not possible, like what are your thoughts on that?
Yeah, so that's a good question. So it's, what is an objective measure of fairness? And there's many definitions of fairness. One definition could be that the algorithm has to be equally accurate for the two groups, equal, rates of false positive, false negative, but overall accuracy of the algorithm could be lower. I mean, there's many definitions, right? And indeed, there's research that shows that you're not going to have an algorithm that meets all these definitions. But interestingly, it is not a lost cause. There is a lot of research that shows what you can achieve from a fairness standpoint that are kind of coming up with good measures that encapsulate multiple measures and kind of say you can achieve these 6 things, if not all 10 things, and so on. And in fact, my colleague, who's a Penn engineering professor, Professor Michael Kearns, is doing a lot of interesting work with that on what's the right definition of fairness. In fact, there's a whole area in machine learning called FAT-ML, fairness, accountability, and transparency in machine learning. And that looks at some of these kinds of things. I think the results are quite optimistic in terms of what can be theoretically achieved. So it's not like, we'll never achieve fairness. I think we'll achieve something that most people will agree is fair. And you can have an academic debate on, hey, you're calling this fair, but it doesn't meet this criteria. But that's an academic debate. At the end of the day, you could have that argument about anything, about human decisions, and so on. You could have an argument in courtrooms, was this fair, was that not fair? But, there are common notions of ethics we all have, and can we meet those notions? Can we meet most of these, can we check most of the boxes? Yes, we can.
Okay, thank you. Thank you, Professor. Thank you, Bing.
Thank you very much.
Thank you for the conversation. We have about 5-10 minutes until we all have to get out of here. So if you want to get a last bite to eat and say something to the professor, please do.
Bing is saying, tell them where to get the book. It's not complicated. On Amazon, on local bookstore, whatever your favorite bookstore is. Yeah.